There is a set of people who try to communicate with others but doesn't go well. Then people call them weird, their brains are not wired properly, and some say they have autism. As scientists, if we look closer, autism is always unique, totally interesting, and sometimes mysterious. Ladies and gentlemen, if I talk to you in a language that you cannot understand, you will not understand. But if we keep a translator or someone in between as a mediator, you will understand. However, there are numerous social robots who are there to interact with children, autistic children. But we are talking about children here. These robots are just something for them, but these kids need someone for them. If you look at these images, these superheroes have visited hospitals and making children happy. These characters, these superhero characters have become the part of those children's life. And we thought, can we take advantage of this? Therefore, we are introducing the Sorting Hat, a mediator social robot with a fictional character appearance for autistic children. In the wizarding world, we have the normal people and the wizards. In our world, we have the normal people and the autistic children. You get the pattern, right? These innocent children are the wizards among us. Even the children without autism, they would wish they had autism so that they could wear this hat. Ladies and gentlemen, our social robot is not just providing a solution for autistic children. We are entirely changing the world how they look at these innocent children. And that's how we created the idea of the first stage of the design process. The robot has three main use cases apart from its ability to sort children into houses as in the movie. The first place is in an environment where his or her friends are there, maybe in a park, a play area, in a school, etc. When a friend comes and talks to him, the hat will identify the emotions expressed by the friend and will tell those to the autistic child, because for autistic children it's hard to understand emotions. And when the autistic child needs to express emotions such as happiness, sadness, those emotions will be identified using the brain waves, and the hat will on behalf express those emotions to the friend. And that's the first use case. The second is in a domestic environment. If you look at currently available social robots such as the QT robot, etc., they train autistic children to identify facial expressions through a display. But in here, the hat itself has a nice face with facial expressions. So the hat will ask to speak out loud the expressions that the hat is showing, and the child could learn those facial expressions. The hat is fully connected via Bluetooth to the mobile app, where the parents could also control the hat and take the best out of it. The third use case is where we have a community of autistic children with the hats. The hats will communicate with each other. There will be head-to-head communication, and the hats will uniquely give various tasks for the children, and the children will start interacting based on the activities given by the hats. The specialty is the head-to-head interaction, providing a gamification for those children. Here's how we built it. The project was started in February 2019 and consisted of 3 phases. At the end of the second phase, we surveyed the project with over 500 participants and with over 10 people's actual brain data. In the first phase, we initially analyzed the facial expressions and the emotions of the Sorting Hat from the movie and frame-wise analyzed those. Based on the types of emotions and facial expressions that the animation had, we 3D printed a skeleton which could accommodate those actions. One of the key drivers for the realistic impression is the skin of the hat, which includes the selection of proper cloth material and the skinning process. We did not use any simulation tools. Therefore, the skinning process had to go through a rigorous amount of trial and error in order to get an exact effect, an exact wrinkle effect as in the movie. With the successful completion of the first phase, the hat was given to 400 volunteers to interact, and feedback was collected based on interactivity and design. The hat was tested and operated for 8 hours straight away for 3 days, which totals for 24 hours in total, consecutively with full performance without burning out during the experiment. The data demonstrate that they love it and the level of interactivity is very high. However, we realized that the hat is weighted 1.7 kilograms, which was too heavy to keep on the head, and the head space where the head is kept is quite tight. Also, the hat's emotions were generated randomly using the 3 Arduino boards which consumed a considerable amount of space within the hat. At the beginning of the second phase, all motors were replaced after the rigorous experimentation in the first phase. In order to reduce the weight of the skeleton, the head was redesigned with carbon fiber in this phase. We also used ultra lightweight material, replacing various metallic components where as possible. For instance, as shown in the slide now, we attached a hollow tube from a pen, which is very much lightweight. Surprisingly, it was durable as well. We also optimized the circuitry, reducing the number of Arduino boards. Finally, we used only one Arduino board and one Raspberry Pi. With such modifications, we were able to reduce the weight nearly by 25%, and we also cushioned the entire head, so it was really easy to wear. One of the major improvements in the second phase, apart from reducing the weight by 25%, is the implementation of a brainwave sensor, letting the head to operate based on the brain data collected. And the brainwaves are also being recorded for future cognitive analysis. At the end of the second phase, the head was given to another 100 plus volunteers to try it out and interact with it, and was surveyed based on the interaction and design. On the other hand, brain data was also collected from 10 volunteers measuring the interactive. However, one of the most challenging aspects of the second phase was maintaining a stable connection with the brainwave sensor and the head. Also, the sensor consisted of one electrode for measurement, which limited us in identifying emotions accurately. Currently, we are in the third phase of the project, where we upgraded the single electrode brainwave sensor with an Emotiv Epoch Plus sensor, which consists of 14 channels. We are also in the process of implementing the algorithms required for accurately identifying emotion, and as well as implementing a computer vision component. The following slide shows the current state of the development with the completed components and the components that we are currently working on. And the next slide shows the user journey and the interaction map of the head when interacting with a human. The head consists of various states such as happy state, a sad state, a sleeping state, and so on. Having said that, we are the team from Sri Lanka, and we hope with the COVID outbreak in the world, everyone is staying safe and taking care. Have an amazing day.